Okay, this is part two of calculating rotor parameters and using the rotor charts. So on this question here, we've got a 4-pole 60 Hertz skim with the following parameters at 75%. Now I'm just going to jump down to see what they're asking for. And in this case, we see that they're asking for the frequency at 30%. So often these questions can give you a lot more values than you actually need. So these parameters at 75%, we're not really even going to need them. So at 100% slip, we know that the rotor frequency will be whatever the stator frequency is. It's at blocked rotor, so if we have 60 Hertz on the stator, we're going to have 60 Hertz induced on the rotor. Now at 30% slip, well, the frequency will just be equal to the frequency at the blocked rotor value times our 30% or percent slip. So that's going to be 60 Hertz times 0.3, and that works out to roughly 18 Hertz. So we'd be about, so if 30% is here, that's going to be 18. There you go. So pretty easy one. Let's try a little more challenging one here now. Okay. So on this question, we got a 2-pole skim, and it's got the following parameters at 75%. It says that we got 2700 RPM, 900 RPM rotor speed, so slip is 2700. Voltage is 1.25. XL, the rotor is 2.5. Rotor is 1.5 ohms, and it wants to know what's the rotor RPM at breakdown torque. Okay, so what we've done with this before is we bring our values at 75% that we need up to 100% slip, or its blocked rotor value. So here's my blocked rotor values. So that's 100% slip, and then here would be our values at 75% slip. And it wants to know, so what are the values at breakdown? So we're not sure what that percent slip is yet. So at 75%, we've got 2700 slip speed. Then we got a rotor speed of 900. The voltage is 1.25 volts. The XL is 2.5 ohms. The R is 1.5 ohms. All right. Well, let's go ahead and let's use the XL at 75% to figure out what the XL is at breakdown, because we can use that in a little bit just to figure out what we are, what our percent slip is at breakdown. So the XL at 75%, or the XL, is equal to the XL, I should say, sorry, at blocked rotor times whatever percent slip you're at. So if I wanted to use this formula to calculate my XL blocked rotor, it's going to be equal to my XL divided by whatever percent slip I'm at. So 2.5 ohms divided by 0.75, and that comes out to about 33.33 ohms. So I'm going to go ahead and put that up here, 33.33 ohms. At breakdown torque, we know that the R is the same as the XL. That's what gives us a power factor of 0.707 in the rotor at that moment in time, is that it's a 45-degree triangle. R is equal to XL. So I know that the resistance stays constant in a skim, and I know that the XL is going to be the same value as the resistance in the skim. So now what I can do is I can use the value of XL at breakdown and the value of XL at blocked rotor to figure out what percent slip we are when this rotor hits breakdown values. So back to this same formula at the beginning here. I'm just going to reuse it again. This time I want to determine the percent slip. So let's just rewrite it. The percent slip would be equal to, in our case, XL at breakdown divided by XL blocked rotor times 100. All right, so that's going to be breakdown is 1.5 ohms divided by 3.3 ohms, 3 times 100. And that should work out to be approximately 45%. All right, 45%. Good stuff. Now let's know what's the rotor RPM at breakdown. Okay. Well, let's first determine our synchronous speed. We know that if we add our slip speed with our rotor speed, those two have to add up to our synchronous speed. So if I want to figure out my sync, I'm going to add 2700 plus 900. That's about 3600 RPM. So slip speed at 100% slip would be 3600. The rotor speed would be 0. So what's our slip speed at 45? So the slip would be equal to N sync times our percent slip that we want. So that's 3600 times 45%. And that's going to work out to about 1,620 RPM of slip. So 1620 slip. What's our rotor RPM? Well, the same formula. The N sync would be equal to the N slip plus the N rotor. So I want the N rotor. So that's my N sync. Subtract my N slip. 3600 minus 1620. It's going to work out to about 1,980 RPM at breakdown. So 1,980. There's your answer. 1980. So in this example, a skim has the following nameplate information. It's a 575 volt motor, 60 hertz, 3-phase, and 1,740 RPM. Blocked rotor voltage is 11.5, R is 0.5, XL is 1.5. Wants us to figure out the rotor voltage at breakdown torque. Okay, so at 100% slip, we're going to have a slip RPM of 1800 and a rotor RPM of 0. You may ask, well, how did I know it was 1800? I know that in a 2-pole motor, it's 3600 RPM. In a 4-pole motor, the synchronous speed is 1800. So the speed of the motor has to be slightly less than the synchronous speed. So we got to have a 4-pole motor here. All right, E of the rotor is 11.5 volts. R of the rotor, 0.5. XL, 1.5. Okay. So how do we determine what our percent slip is at breakdown? Well, we know that at breakdown levels on this rotor, the resistance is constant, 0.5, and that XL is the same as R at breakdown, so 0.5. Now we're going to use these two percentages to figure out what percent slip we're at. So the percent slip, in this case, will be equal to the XL at breakdown divided by the XL at blocked rotor times 100. So 0.5 divided by 1.5 times 100, and we are at 33%. 33.33%. So there's our blocked rotor values, or sorry, breakdown value, breakdown slip, percent slip. Now all we have to do is convert our, see what our voltage is at 33%. We know that's directly proportional to our percent slip. So the rotor, E of the rotor, is going to be equal to E blocked rotor times our percent slip. That would be 11.5 times 33.33%. That's going to work out to be about 3.83 volts. There you go. Anyways, we'll see you on the next video.